Hi, it's Art, coming to you from the West Hall at OFC 2026. I'm here, joining me here is Sandeep Sani, Head of Packaging of Lightmatter. Hi, Sandeep. AI, co-packaged optics being a huge topic right now.
Absolutely.
You have a solution that you just unveiled here at OFC. Can you tell us about it? And it's the vClick.
It is vClick, and the reason we are calling it vClick is because the way we are bringing light out of the photonic IC is vertical instead of coming at the edge of the PIC. And that's why we are calling it vClick, vertical expanded beam, and click because it's a detachable solution.
Okay.
And it is mold and grind compatible, which is a very critical feature of it.
Okay. So what does vClick solve that other FAUs didn't in the past?
Absolutely. So if I take a step back, Lightmatter is really good at building 3D optical engines, which essentially means the EIC is bonded on top of the PIC. And we leverage existing process flows in the industry called chip-on-wafer flow.
Okay.
Now, when I do this flow, the traditional methods of attaching fibers at the end of the line, end of assembly, using V-grooves or butt coupling doesn't work. So we had to solve this problem by bringing the light vertically up. And also by doing so, we are able to not only bring a known good optical engine to the market, but also it allows us to be compatible with all the advanced package technologies. So it's a very important aspect that this technology is compatible with mold and grind solutions that are very popular in the market, and also with technologies such as EMIBs and whatnot that is very prevalent in the market.
Okay, that is great. And obviously, right now it's cutting edge technology. It's what's defining the next steps in co-packaged optics. Am I correct?
Absolutely.
So the detachability at the manufacturing stage, how is that affecting CPO, co-packaged optics now?
Yeah, one of the primary things we need again, if you look at fiber attach, has been one of the biggest challenge in deploying CPO into high volume manufacturing. Right? And previous methods, which had V-groove based fixed FAU, are not very easy to manufacture through the assembly flows and when it goes to system integrators. This is where detachability becomes very critical. And not only critical in that aspect, but also shifting left towards the wafer scale process technology and providing detachability is very essential. Because you can imagine that having to build that optical engine, and for end customers, you want to provide them a known good optical engine, which has proven all the optical links are working. And then they can integrate in that optical engine to their existing process flows. And hence, having a known good optical engine, having a detachable FAU technology is essential for us to bring this CPO into high volume.
Okay, so I want to ask you one thing because you mentioned it, and I just want to get that out to everyone that is still learning the vocabulary or the lingo. You mentioned shifting left.
Yes.
And I do want to ask you, what is shifting left?
Okay, very good question. So think about it like this, right? Today, if I look at the old technology, you would attach an optical engine onto the package or substrate along with the rest of the chiplets that are sitting already onto the substrate. And then you come and attach the fiber attach at the end of the assembly.
Okay.
So imagine if I have issues by attaching the fiber attach, if some yield loss associated with fiber attach, things don't work out, I have to throw away the whole package, which has bunch of XPU, HBMs, and the optical engine. So it's very ineffective, cost-sensitive solution. Now, shifting left really means is we want to build and provide a known good optical engine and really test this whole connectivity, which is the fiber attach and everything, at the wafer level. So you do that the optical coupler attach at the wafer level, you pre-test it. So you know your photonic IC is working as expected. And then attach that optical engine to the XPU complex rather than doing at the end.
Okay.
So that is really shifting left, what I call.
Okay, that's great. So this engine right now, detachability, you're using Senko connectivity and detachability technology, which is the MPC and the seat. Can you just tell us why you chose Senko for this?
Oh, very good. So this is a number one. Both Lightmatter and Senko team are thinking in the same way. So there's the visions of both our companies are aligning very well, and it's like solving a puzzle. So we are bringing certain things to the market, like the lens attach at the wafer level is something that we are bringing to this puzzle. What Senko is bringing with their seat technology is how the receptacle is attached to these lenses at the wafer level, and how the detachable FAU comes along with it.
Okay.
What Senko has accomplished is really the seat technology and the receptacle, which is extremely precision alignment that you can achieve, and also passive alignment of the detachable FAU to the lens area. So it really becomes a very synergetic opportunity between the two teams to come together and solve this problem that everybody is facing right now.
Okay. Well, you said that Senko and Lightmatter have the same vision. Great minds think alike, right?
Absolutely.
Yeah. So, Sandeep, to finish the interview off, if for people watching, if there's one thing that you would want them to take away from the vClick at OFC, what would it be?
We are solving a very toughest problem that has plagued the industry for a long time. With partnership with Senko and Lightmatter, we are moving forward to bring this technology to high volume manufacturing, so that we are really gearing up to be ready for high volume deployment in next few quarters.
Oh, Sandeep, that's great. Everyone from OFC 2026 in front of the Lightmatter booth with Sandeep. This is Art. Thank you very much for having me here, and thank you for sharing your knowledge with everyone.
Thank you. Thank you for this.
Thank you for watching.